Hey guys, just making another video to help you guys out. This one's going to be for the LearnZillion assignment in Module 3, 1.6.1. Again, you guys can either find that by logging into Canvas, and in our Module 3, you'll see it if you scroll down. It's going to be right here. It says LZ Digital Practice Problems, Algebra 1.6.1. If you guys log into Clever, you guys can click this LearnZillion assignment and then look for the assignment there as well. Again, I'm going to go over just a few of these, not every single problem, but this will help get you guys started. And again, if you guys have any questions, you guys can ask me or whoever your teacher is, and we will be happy to help. So this one is a little bit of new material, stuff we were going to get into before we started our distance learning. And this is going to get into quadratics. Those are those things that are U-shaped. So to start us off, it says, here are a few pairs of positive numbers whose sum is 50. So again, sum is going to be that word that means adding. It says, find the product of each pair of numbers. So the first number is 1. It has to add to 50, so our second number has to be 49. And so the product of those two numbers, 1 times 49, is just going to be 49. All right. So then it asks us to do the same thing, but now the first number is 2, and we got 48. So we get 96 there. And here we've got 10 and 40. And when I multiply those, I get 400. Okay. So that's just filling out the table. So let's find a pair of numbers that have a sum of 50 and will produce the largest possible product. Now, you could make a table, you could run through a bunch of numbers, but you can see right here that as our first number is getting bigger, our second number is getting smaller. This pattern, it looks like our product is getting bigger. You can make a table. What you're going to eventually find is something like this. Let's just pick some numbers. So we'll do 20 is my first number, and that would mean 30 would have to be my second number. And so when I multiply those, 20 times 30 gives me 600. I will do 30 times 20. If I'm following that pattern, I should get that same thing. I'm just switching the order, right? We did 10 times 40 was 400. And we had 2 times 48. These are not in any, perfect order, but we ended up getting these numbers. And so what happens is it's getting bigger, bigger, bigger. Somewhere in between here, we get back down to 600. What you're eventually going to find is that when you get 25 times 25, that's going to be your biggest number. And so what you're going to get right there is a product of 625. This is kind of introducing us to that shape of a quadratic and the pattern, things that quadratics follow. So what is the product of those two numbers? 625. So how did you determine it has the largest product? So what I did, I knew it, but what I did, I kind of showed this was, it's not a table with every single number, but, I made a table. Maybe you did this before, maybe you used guess and check, okay? But how did you find that, okay? And so again, this is just introducing us to the beginning of, quadratics. Again, make sure you guys aren't just doing the first problem on these assignments. A lot of us are only doing the first card. There's 9 cards on this, so click next. So now it says, here are some lengths and widths of a rectangle whose perimeter is 20 meters. Well, think about what perimeter means. Perimeter is the length around the outside of a shape. So we've got a rectangle, right? And we've got our length and our width. Now, here's what might trip some of us up. It has a length of 1, has a width of 9. You can switch those, interchange those. Well, that's only 10. what about our other 10 meters? Well, remember, in a rectangle, opposite sides are going to be the same there. So to find the area of a rectangle, we multiply. And so you guys can fill out this table, 1 times 9 is 9, 3 times 7 is 21. I'll do this one right here and let you guys finish the rest. So if the length is 5, right? So if I'm drawing another little picture here, and it's not drawn to scale, then my opposite side also has to be 5. Well, how much total space do I have? How much, what's my perimeter? 20. Well, I'm using 10 already, which means I have 10 left, and both sides have to be the same. So I'm actually going to end up getting, 5 as my width as well. I multiply those, I get 25. Okay, you guys can fill out this. You guys can pause this video if you need to. You guys can fill out this and, figure out what that pattern is. So once you fill it out, you should notice a similar pattern to what we did last time. The area is going to get bigger, 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 and then all of a sudden it's going to start to get smaller. So the area begins to get bigger, but then starts to get smaller. That's going to be our general pattern for quadratics. All right. So without calculating, predict whether the area of the rectangle will be greater or less than 25 square meters if the length is 5.25. So this is introducing decimals, but we don't even need to do the math, because what you should notice in this table is you get the largest area when the length and the width are the same. So will it be greater or less than? Well, our biggest area is 25 when the length and width is 5. So 25 square meters, because be less than 25 square meters because our largest area occurs when the length and width are 5. So here's another one of those graphs you guys need to do, and so we can plot these points. So this says length and area is what we're comparing. So I'm going to graph this first column and this last column. So 1 and 9. I don't think it's going to let me do it. Oh, yeah, it does. 1 and 9 right there. Then I've got 3 and 21. And then I've got 5 and 25. And you guys can fill in the rest of this there. If this is not absolutely perfect, that's okay. Now, it's going to ask you, do the values change in a linear way? Well, that word linear has what word in it? Line. Do these follow a straight line pattern? No, it's starting to curve right here. All right. So is it linear? No. All right. From what we've done, exponential either starts out slow and then grows fast and keeps going, or it grows fast and then slows down. When you guys finish this graph, you guys should get something that looks sort of like this. Okay, my graph's not perfect. Now, linear, straight line all the way through. Exponential, it's going to curve and then keep going. But what's this do? It goes up and comes back down. So this isn't linear or exponential. This is going to be what we call quadratic. So card 3 is going to talk about more or less the same stuff. I'm going to let you guys go ahead and work on card 3 on your own. Card 4, it says, which statement best describes the relationship between a rectangle side length and the area as represented by the graph? So again, we're looking at rectangles. We're looking at the length compared to the area. And so we want to see, what's happening here. As the side length increases by 1, the area increases and then decreases by an equal amount. So is this always going up and down by the same amount? No, it's growing kind of fast here, gets a little smaller, a little smaller, a little smaller. This stays the same, right? It begins to curve back down, and then down here you get like a big jump. So is it always increasing or decreasing by the same amount? No. As the side lengths increase by 1, the area increases and then decreases by an equal factor. As the side length increases by 1, the area does not increase or decrease by an equal amount. Or as the side length increases by 1, the area does not change. Well, we can see very clearly that the area does in fact change, okay? Now, this equal factor would mean we're multiplying by the same number over and over and over again, which would bring us to exponential. But what we have is it's not increasing or decreasing by an equal amount, so we're going to choose C. All right. So this is a little bit of review. This tells us how big each book is, and you're going to fill out a table. You're going to answer a few questions. This is stuff that you guys hopefully are able to do. And if you need to look at some of the other review videos, you guys can go ahead and do that. So that's card 5. This is also a little bit of review with exponentials, but I think this is going to be the last card I do with you guys for this video. So the value of a phone when it was purchased was $500. It loses 1/5 of its value per year. Now, if you had me as a teacher, you would hear me say a lot of times, we want to find the part that we keep is what we want to use for our exponential equations. So the value of the phone was $500. It loses 1/5, so it keeps. So it's $500. It loses 1/5, so it keeps 4/5 of its value. So what we want to multiply by is the part that it keeps. So we actually want to take our $500 and we want to multiply by the 4/5 of the value that that phone keeps. So to find it after 1 year, I'm going to multiply by 4/5. Well, what I'm going to get right there should be 400. I can type that in my calculator to double check that. So after 1 year, the phone is worth 400. Now, what I'm going to do to find how much it's worth after after another year, I'm going to take my 400. Well, it's going to keep 4/5 of its value again. So I'm going to do 400 times 4/5. And so I type that in the calculator like that, and I'm going to get 320. So now I'm going to do the same thing again, always using my previous value. So I get 320 times 4/5. Oops. 320 times 4/5. Make sure I type that in right. And so I get 256. So I can fill these in. So after 2 years, it was 320. After 3 years, 256. Now, Tyler says that the value of the phone decreases by 100 each year since 1/5 of 500 is 100. Well, 1/5 of 500 is 100. And so it does go down $100 its first year because it was $500. But does it go down down 100 every year? No, you can very clearly see that it does not. So Tyler is not correct. So why is he not correct? I'm going to leave that for you guys to explain in your own words. Guys, make sure you finish the last few cards on this. And again, as always, if you have any questions, please reach out to your teacher and ask if you have any questions. Guys, have a good day, and I'll post another video soon.